Thank you for joining myself, Chrissy Boland, part of the Wenzel sales team, and my colleague, Drew Pensko, one of our applications engineers. Wenzel America is part of the Wenzel company. We're a global corporation that has been family-owned for over 50 years. We pride ourselves on being customer-focused and flexible. Today, we're going to be presenting the SF87 shop floor CMM with Revo 5-axis probing system and our Quartis software. I want to take a moment and mention to everyone to please ask us questions through the GoToWebinar tool, which is the question mark icon in a bubble, which is located on the toolbar on the right-hand side. It should be under the hand icon to raise your hand, which you may also feel free to do. We'll address your questions at the end of this presentation or after the presentation. The Wenzel SF87 series of CMMs were specifically designed for the shop floor environment. Our SF87 is a cantilever design. This allows operators to load and unload from 3 sides. Its small footprint offers an ideal solution for automation cells. The SF87 is a very flexible system. It has multi-sensor capabilities. Though we're presenting it today with the Revo 5-axis probing system, you could also configure the system with a tactile probe or an optical system or scanning probe. We not only offer it with our proprietary Quartis software, but then again, you can also specify it with Modis, Metrologique, Polywarps, and OpenDemus. This provides our customers with options that will meet their specific needs. One of the things I'm really excited about talking to you about today is our 5-axis probing. You may not be familiar with 5-axis program, so I briefly want to give you some things to look for in the upcoming demo. This technology uses synchronized motion of the CMM and the head axis to maintain the machine's dynamic error at ultra-high measuring speeds, which allow for better accuracy. Now we're going to show you a brief video of 5-axis in motion. This video is showing you the Revo 2, the latest in the Revo product line. You can see we're scanning the surface now, a curved surface. Now we're doing a helical scan. There are options you could have with the Revo 5-axis. You could put the camera on it, you could do surface finish.
Yep, RSP3 also because the RSP2 that does the 5-axis scanning, it's capable of up to 500 millimeters of probing length, whereas with the RSP3, you have up to 800 millimeters for traditional satellite and up to 600 millimeters for crank with the RSP3. We scan a curved surface, no problem. And here's just a flat surface as well too, Christy.
Yeah.
Really.
Scanning the edge again.
Yeah.
Another sweep scan of the curved surface.
You can definitely see the speed too. It's just blurring back and forth.
And the amount of data it's collecting.
Yeah, the data and the throughput.
Now what I'd like to do is turn things over to Drew, who will be presenting us with a short demo.
Thank you, everyone. Thank you, Chrissy. My name is Drew Pensko. I am an applications engineer here at Wenzel America, recently joining in July of 2020. Where before that, I was an assistant plant manager for a small tool and die company, and today I'm here to show off. So the main shell of this is our Quartis software. Then we see the SF87, and then right here we have the Revo probing system. So you can see our Quartis software, Windows-based software. It features a ribbon system. So you can see right here, if you ever use Office, each one of the three basic tabs, machine, measure, and features ribbon, has a drop-down menu with a graphic for all your different commands, and it's very similar to running Office. So I'm going to go ahead and start to run our program here and here we go. So I'm going to go ahead and move this window out of the way while the Revo just does that quick plane scan right there. And then I'm going to stay zoomed out because this is where we get to really see the five-axis technology. You see that machine is not moving and that the primary movement is coming from the head, the two drives in the head. So that's getting that stability, reducing that traditional machine drift that you would get from a three-axis system. And then I'm going to go ahead and just zoom in real quick so we can see each of these little circle scans real quick as we get the dowel. And then go to this harder to access feature right here. Here we can see in Quartis there's this purple dot. That's a fixed focal point. I programmed it, just put that line there. The Revo stays on maintaining contact on the part, and it's just going to move around while maintaining that point. So with 5-axis, it's really good for these hard to access features. So I'm going to go in after this scan right here, do a quick helical scan of that cylinder, and then get the outside wall right here, no problem, in between. And you see that the Revo is just aligning itself with the coordinate system. That's the benefit of 5-axis. And then here we have the sweep scans that we were all waiting for. Right there, little quick drag for this flat surface, another quick drag, and we're done. And then after this, we do curved surfaces as well. So I'm going to zoom out so we get a better look with the machine and the Revo moving back and forth. And you can see in the progress window up here all the points that we're gathering. So there hasn't been, in my program, I haven't had to do any sort of indexing or angle changes. As you see here, I'm going to go ahead and do a jump view to this pocket as the machine just does a 5-axis move. And then we go into the corner right here. There was no need to program with the traditional 3-axis system, you're looking to calibrate the angle change, but with the Revo, one calibration, all your angles. Quick touch trigger points right here. Revo does do touch trigger as much as we're talking about scanning. Go around right here, grab the pocket, and then zoom out while the program's finishing. So a couple things about the Revo, as we mentioned. There are multiple sensor options and stylus changing capabilities with the RSP2, RSP3, surface finish, and with the tool rack, you can complete your inspection process easily. Now you can see here we have our report. So with our report right now, I'm going to go ahead and just slightly go down, and you can see here we have a table and this little plot of all our points from this cylinder scan right here. Go to page 2 right here, and then we see that we have just a traditional table style report with all our dimensions, all our measurements right here. Here's an ISO 286 call for this hole right here. And then on page 4, I have the CAD and some bubbling right here with the nominal values for each of these holes that I've done and their actuals all on here. Landscape, easy to set up in Quartis. And then on the last page right here, showing off our sweep scanning, here's our sweep scan. So this is a feature graphic. So this is all the details that went into the sweep scan, all the points, and I even put a nice color grid right here so you can see how far we're deviating off the nominal. And then and then I'm going to go scroll down just a bit, and then we can see also that I have this on the CAD as well. So in my past job, I was doing an inspection report for investment casting, and this is great you sweep scan a giant area really fast, really quick, all the points and all the data, and you can show them, you can easily go and show them this and see where they need to make adjustments to the mold if they have to for a casting. All right, so that's just a quick rundown of the report, but I'm going to go through how Quartis operates. So as I mentioned before, it's a Windows-based system. So I'm going to go over to the database real quick, and you can see that Quartis stores all its information into databases. So the measurement database is where you would store your work piece, a program, all the different programs, the graphics, and different measurements and the features. And going in and making a copy of a program is super easy. All I have to do is just go to the program right here, say I need to make a copy, go ahead, copy, paste, and then enter right here a name for our program. And I've already made a copy of this program, so it was super quick and super easy. This is where all our program information is stored. And then we have a system database with all the probes, reference spheres, and palette coordinate systems, so you can bring those different coordinate systems across to your different measurement databases. All right, so I'm going to go ahead and give a quick rundown of how we measure things in Quartis, because this is what we're all here for. And I'll show you how easy it is to use the Revo in a 5-axis system in our Quartis software. So I'm going to go over and with my mouse over the graphics window, go back to our graphics. And we see right here we're, at a traditional A0, B0 angle. But let's say we need to go and just measure the circle. So I've talked enough that I didn't make any indexing changes, so I'm going to go ahead and prove it. So I'm just going to go ahead and click on what I'm measuring, right-click to accept the measurement, and just hit start. And I'm going to zoom out. Revo's going to rotate, find that angle, go in. There was no indexing. There was no changes. It's really, really convenient. And let's say I forgot something on top. I'm going to go ahead and just pick this hole up top right here. Go ahead, select. And then without having to index my angles, go up above. There we go. Super easy to, based on the Revo is just aligning to the part coordinate system. It finds the right angles. It's really, really great. So I'm going to go into our features tab right here where we have the main 3, which is the control of the machine, how we measure things. Let's go into what we can report our measurements as. So you can see right here, there's a settings window. There's a settings window in front of, it's always your first option in Quartis, so you always go left to right, so you can always make adjustments to your settings right here before you do anything. And then we have the capability to go from ISO to ASME right here, your form, standard, and then your GD&T, your straightness, flatness, cylindricity, position, symmetry, all those things right there. So Quartis is a Swiss-made software, so it's really well built and well designed, especially the help system. So even if I'm stuck on something, all I have to do, let's say I need help with a 2D angle. I'm going to mouse over real quick, and then I'm pressing F1 on my keyboard, and then instead of just opening the help file, it opens the help file, and it takes me exactly where I need to go in the help file. So even if I don't know anything, I can go into Quartis, mouse over, hit F1, and then I have all the pictures and a step-by-step guide of how to execute what needs to get done. This is also, I use this all the time too for even just understanding how certain things work in Quartis. You can always just mouse over something, hit F1, and you can get a nice understanding of how Quartis does things, which is super great. So with our measurements also comes our statistics in Quartis. So if I go over to the statistics window right here, and I go ahead and click, and while this loads, all our data, here we have all the different features and measurements that I've taken. And this also went, so first, let's get to our statistics window, take that, and then we can see we have CPK and machine capability. So we can do that. And then we can filter this as well. So we can take certain features, limit them within a certain deviation of how we want to know how good the good parts are, how bad the bad parts are. That's easy. And then we can also filter via the measurement. So if we want to know how the first 2 runs are, we select the measurement filter. We can select, okay, we just want the first 10 runs. Or let's say we need to know it for the week of this, let's say the 17th to the 25th. We can do that there. So I'm going to go ahead and exit out and then show our statistics. So I'm going to go over to number 18 right here. And you can see I have this page, the data page right here of the work piece, feature 18, and our CP and CPK. But I can also go to the overall view, and I also have a trend diagram right here of what our actual values are across each measurement, and a histogram as well. But we can also save and export this data by just right-clicking and hitting the save icon right here, the copy or print option. So I'm going to head back over to the report real quick, and you can just go over the quick, easy way to set up a report in Quartis by just selecting a new page right here, and then we can go ahead and just insert a table right here or insert a graphic. So, Chrissy, do you have any questions for me so far, whether it's about the Revo, Quartis?
Yeah. So you've given us a lot of information in a brief period of time. In the beginning, you talked about a fixed focal point. I wonder if you could take a moment and go back and explain to us a little bit more of what you did.
Yeah, no problem, Chrissy. So I'm going to go back to the graphics window, and then I'm going to go review a circle. This circle, circle 5. So I'm going to go ahead and double click right here. And I'm going to go over to where it says head orientation, because right now, so we're working left to right as we do in Quartis. So here's the geometry. Here's the X, Y, Z, the size of the hole, all that. Here's the distribution where we can set all the scan parameters. So we're taking a point every millimeter, the probing depth, sector. We can all change that. And then right here, we have the safety plane in Quartis, which features the yellow line of where the ruby is going to follow. The red dot is where the ruby is going to go before the measurement, so we don't slide into anything. And then we'll go to the head orientation. This is what you mentioned, Chrissy, the fixed focal point. So right here, you can see this purple dot, and I can adjust the parameters right now. So I can adjust either the X, Y, and Z values of this scan so that the Revo will maintain this center point right here. It's going to stay there, and then it's going to move around while the stylus stays in that same direction. So right here, I hit accept. I changed that from 60 to 55. So I'm going to go ahead and rerun this. See what this looks like now. And as you see right here, really fast, you can see that the Revo was staying right there on that point. We're collecting a point every millimeter here, so it was a pretty fast scan. I could have slowed it down. But this is all about the fast throughput, lots of data, and flexibility, Chrissy.
Another thing that I noticed, you had mentioned you didn't have to do any indexing or change the angles. You did a jump.
Mm-hmm.
Can you show us that again?
So yeah, so I haven't had to do any changes to the angles right here, as I've shown off before with measuring these circles and the cylinders. But the jump view I did is something I did in the display ribbon. And right here, so in combination with the display ribbon this little bar underneath the ribbon is a quick access bar. So I'm going to go ahead and add something to this quick access bar by going to Quartis, into the Quartis options, and then going to the quick access option. And then I can create a shortcut for pretty much anything in Quartis, and it'll be right underneath there. So I had a custom view set up there, but what if I just want a standard view? So I'm going to go over to the display, hit the and then click display, click view, and then I'm going to go ahead and select a traditional, so view, hit the check mark, add that to our toolbar, okay. And here, now I have the shortcut to go ahead and let's say I need to look from top of Z, or if I need to go to the south, back to southwest, right here. And then I also have a custom view that I created. So you can have custom views in Quartis where you can save them, create them. I can go from this pocket right here or behind the part right now, but I have the machine blocking the way. So if I just turn off the machine and I can show off the behind view right there, we are behind our part. And then go ahead to our pocket, back to our pocket, and then I can go ahead and easily switch back to any views right there.
It's really customizable.
Oh yeah, the quality of life you get with Quartis is really, really amazing. Anything else you got for me, Chrissy?
Yeah, so we've seen a lot of the sweep scanning, but how difficult is it to program the sweep scanning in Quartis?
It is not that hard at all to do a sweep scan in Quartis. So we can sweep scan a plane, we can sweep scan a surface. So I'm going to go back and sweep scan so sweep scanning a surface is really simple. I'm just going to go ahead and just start recording our program because I want to write this down in our program. Just hit it right in the window, go ahead and select measure, and then select our surface. Go ahead and left click on our CAD model for our surface. Right click to stop, and then I'm just going to select a distribution. So I'm going to go ahead and just take a couple points right here. And then right click to accept. And you can see our little path right here that Quartis has generated for us. I can change this path right here with the distribution window. And then in the distribution window, let's say I need a tighter wavelength, I need more sweeps. Just bring this down just a bit. All right, there we go. We can change how many points we're taking per distance. So right now, let's take quite a bit more points. So every 1/10 of a millimeter, I'm going to go ahead and take a point. Set ourselves up with the head orientation. Make sure we're dragging. We're good, and we're going to go ahead and start. And right there, you see the progress window. And there was 7,000 points in just that little, quick, easy-to-program sweep scan. And we even have the colors right there you can see of the feature of all the points too as well.
So Drew, let me ask you, you're new to Wenzel. Having just used the Revo for 2 months, what do you like best about the Revo?
Definitely the Revo is it's highly flexible. With all the different tools and options and modules you have, especially for a shop floor machine like this, you can complete your entire inspection arsenal, including surface finish, with just one probe. And just with a simple tool where I can tool change, you can change it to go from RSP2 after you're done with with all your 5-axis scans and then go into surface finish and then set up the surface finish and then finish surface finish. So you're getting the flexibility for all your current applications and only for the future as well. And at a high speed too. So you're increasing your throughput while still getting a lot of high accurate data. So the Revo is just a fast and I like to call it the fast and flexible system.
Okay. So I know everyone's experienced this. They've gotten a job in, they've created the measurement program for it, they've completed it, they've gotten all the data, they've sent the data to whomever, and sure enough, an email pops in and says, hey, that's great, but can you add the following 3 elements? We now want to take a look at them. Drew, how difficult is it, and can you change and add more elements into a Quartis program?
Yeah, no problem. So let's say we forgot to add true position to, we forgot to add true position for one of these holes right here. So let's go in real quick and let's grab, oh, right. I don't remember which one I named it. There's a big giant list of circles. So the great thing with Quartis is I'm just go ahead and make sure the mouse button's selected. And I just click on the CAD model, and there we go. I now have the element I need to measure. And our tolerancing is set up very similar to a GD&T print. So go ahead and just fill in our datums right here really quick. And then the last datum. And, oh, wait, this is an ASME, so I can just go ahead and click ASME while I'm still evaluating, and it doesn't change the calculation. So we can go in and accept that. So I'm going to go to our report now so we can add this to our report. Go ahead, get to our report right here. I'm going to double click on our table. And let's say we need to add those 3 measurements we were talking about earlier, Chrissy. We add them, and then we can move them onto up and down the report right here as well. But let's just leave them at the end of the report. We have the option though you can arrange things really easily through the table. Now I'm going to go to page 3, the second page of this table, and there we go. We have these 3 dimensions added, but we can also do that with our graphical report as well by just double clicking as well, opening up this selection right here. Go ahead and take another look right here. Go ahead, and then we can add this right here with this window. Hit OK, and then it's going to tell us show us our view. We go ahead and we adopt that view. Our view is fine. We're good. And then we can also drag this window out. And then we see here, that's added to our graphical report as well. It's really simple, really easy.
Okay, so we only have 2 minutes more. Maybe one quick question I can squeeze in there, and the rest we'll answer offline and get back to everyone. Drew, can you do condition statements within Quartis?
Yes, Quartis can do. So if I go to my program window right here, and then I get out of the edit mode and get into record mode, you can see that you have a bunch of different options for your program, including looping, branches, and jumps, and marking and creating subprograms as well. Any other questions we have?
I'm afraid that's all we have time for, but I want to thank everyone for joining us, especially taking time out of your busy day. If you have any additional questions, please feel free to reach out to myself or Drew Pensko via email or phone. We'd be really glad.